get going. Let's jump right in. How did we feel on a scale of 0 to 10? So 0 means we absolutely hated it. 10 means we loved it. How did you feel from 0 to 10 about exponents in grade 8? So when you did exponents in grade 8, how did you feel about them? Can you give me a number and can you chuck that number in the chat for me? Okay. All across the board. Keep them coming. So all I'm wanting to know at the moment is between 0 and 10, if 0 is absolutely hated it and 10 is absolutely loved it, how did you feel about exponents in grade 8? Just so we can get an idea of where you're all at. 7.9, love it. Very exact. Okay, so when we are talking about exponents, it means that we have that tiny little number at the top of another number. So in this case, this 5, that's our base. So this is our base over here. And this 2 looks bigger than it should. That is our exponents. Okay, and another word for exponent is power. Another word for it is an index or indices. All of those mean exponents. If you hear any of those words, that's what that means. What does it mean for us to have 5? So we would say this, if we had to say this as a sentence, we would say that this is 5. Sorry, let me move it over here. 5 to the power of 2. That's how we would say what's happening on the board at the moment. How would I write that in a different way? How could I write 5 to the power of 2 in a different way without using exponents? Who thinks they can help me? Yes, Sunday. How can I write 5 to the power of 2 without using exponents? Great answers coming in through the chat. Beautiful. Okay, so if I'm wanting to write this without exponents, I could say that that is 5 times 5. Oh, yes, hi. It's okay. All right. So just be careful. If we have a power, it's saying, like, if I had, let's write it like this. If I had 5 to the power of 3, that's saying I've got 3 5s. So I've got 5 times 5 times 5. If I had 2 to the power of 4, that means I've got 2 times 2 times 2 times 2. Okay, so just be careful. So it's not going to be 5 times 3 or 2 times 4. It's going to be 5 times 5 times 5, 2 times 2 times 2 times 2 times 2. Okay. So that's just like your basic idea of what is an index and what is an exponent and what is a base. All right. So today we're going to look, oh, sorry, before I jump on, does anyone have any questions about this or feels confused or would like me to explain something further before we look at some questions? And don't ever feel embarrassed to ask for help. If you don't know what's going on, just let me know. Okay. Cool. So the first law of exponents is when we are looking at multiplication. All right, let's just have a look, see what this chat. In one test, my friend had to write 5 times 5, but there was a typing error and it said sent to the power of 60, 5 to the power of 60. Oh no, that's not great. 5 to the power of 60, if you had to write that out the long way, that would take forever. Okay, so law 1 is multiplication, and that's saying that when the bases are the same, so remember when we just spoke about what a base was, it was the 5. In this case, the x over here and this x over here, those are our bases because the a and the b, those are our powers or our exponents. Okay, so when the bases are the same, So you can see that they are both x's over here, okay? And we are multiplying those two things that have the same base. Then what we're allowed to do is we are allowed to add the exponents. So our base stays the same. Our base stays as that x, and we can add those exponents. So we can say a plus b. Now, I know that sometimes this gets a bit confusing when we're dealing with letters. So let's look at it if we had numbers instead of an a and a b. If I had x squared and I was timesing that by x cubed, okay, my bases are the same. So my base is going to stay the same. And all I'm going to do is I'm going to add my exponent. So I'm going to say 2 plus 3, which gives me 5. Now, the reason we can add those, the reason it is x to the 5 is because if I wrote out x squared the long way, like I asked you to write 5 squared out just now, you said 5 times 5. So x squared would be x times x. Remember that dot means multiply in maths. Okay, and if I had to write x cubed out, I would have times x times x times x. And what I land up with is 5 x's. I've got 2 from the first one and 3 from the second one, and that is why my final answer would be x to the power of 5. So whenever our bases are the same and we are multiplying them together, we can just add our exponents. Feeling okay? Any questions? Okay, cool. Cool. Let's give on a try then. So let's start with this one over here. Will the exponent always be the same? The exponents will depend on how many numbers you're adding, which I think will make some sense when you're looking at this question here. So I want you to give this one a go. Tell me what you think the answer would be. And then we're going to talk about, there's a very common mistake that happens in a question like this. So as soon as you have your answer, I want you to put that answer in the chat for me. And then we're going to chat about the common mistake. So put whatever you think the answer is, don't panic. All right, so we seem to be in two minds between x to the power of 6 and x to the power of 5. I can confirm that one of those is correct. Let's work it out the long way before we do anything. So let's do this the long way. X squared would be x times x. X cubed would be x times x times x. And then we've got this sneaky guy over here, which would be times x. With that, now that I've written it out the long way, does anyone want to change their answers? Have a look at it and see if you want to change your answer. Yeah. So there's 6 x's. There's not 5. We've got 1, 2, 3, 4, 5, 6. It's going to be x to the power of 6. The reason that it's 6 and not 5 is because there's no 1 happening over there. But remember, if I have like a y, or if I have an a, or if I have a b, or if I have a q, all of those are to the power of 1. It's just that we don't write it because it's not necessary. So whenever there is a variable like that and it doesn't have an exponent, you can just put a 1 there so that you know that there's a 1 that you would need to add. And then you can just add those numbers. So what this would be looking like is we would say that's going to be x to the power of 2 plus 3 plus 1, which gives us x to the power of 6. Okay, Chi-Chi, yes, how can I help?
Ma'am, can you hear me?
Yes, beautifully.
Ma'am, what if we had numbers to simplify? If it wasn't the exponents, what if we had
So,
numbers?
like if you had 2 to the power of 2 times 2 to the power of 3. Is that what you're meaning?
Yeah.
Okay. So you would do exactly the same thing. If the base is the same, we can just add the exponents. So let's take this as it is. So we're going to have 2 to the power of 2 times 2 to the power of 3. Okay. Our bases are the same because our bases are both 2. So we're going to keep the base the same and we're going to add our exponents. We're going to say 2 plus 3 gives us 5.
Oh.
Yeah.
So easy.
So cool, hey?
Yeah. Thank you, ma'am.
No problem. Anytime. Okay. What if we learned to multiply the exponents as well? Okay, so when we multiply exponents, we only multiply exponents when we have an exponent to an exponent. So for example, if I have x to the power of 2, and that's to the power of 3, then I would multiply those exponents. So in this case, we're not going to be multiplying them. We're only going to be adding them for this first rule. Okay. Let's try another one. Ooh, now we're getting spicy. Okay, I'm sure you remember SNV from Teacher Sam, signs, numbers, variables. We're going to be talking a lot about this during the section, signs, numbers, variables. Okay, we'll chat about it as you give this question a try, but have a look. See what you think the answer would be. Remember, making mistakes in maths is a good thing. When you make mistakes in maths, it means your brain is growing. It means you're making new connections. You're figuring things out. So making mistakes is not a bad thing. Give this a try. See if you can figure out what the answer would be. And then we're going to quickly chat about and put the answer on the board and go on to our next one. You guys are being superstars this evening. Oh, getting all kinds of different answers coming in now. When I had x squared and I was timesing that by x to the power of 3, what was I saying about these x's? What was important? Why was I allowed to add that 2 and the 3? Because they're the same. The x's are the same. They have the same base. Okay. And so we need to be careful when we're looking at a question like this. We can only add exponents with the bases that are the same. So when you're having a look at this, you've got this x here, you've got this x here, and you've got that x there. They all have the same base, so we can add their exponents. And then you've got this y, and this y squared, and this y cubed, so we can add those exponents. So be very careful, assess your answer, and then I'm going to pop it up on here. Yeah, Azandre, how can I help? Hello?
Ma'am, so what if we did it like x to the power 6 plus y to the power 5 equals xy to the power of 11?
Okay, so we can't mix our x's and y's, so we can only add ones that have the same base, because it's like 2 completely different things. It's like then we're saying we had 3 oranges and we had 4 apples, but now we have apples and oranges and there's 7 of them. Does that make sense? So we have to keep how many there are of each of those later. We're not allowed to mush them together.
Okay, thank you, ma'am.
No problem. So when we have a look at this one, sorry, what we're going to want to do is we're going to have a look at our x's first. We've got 2 in the first one, then we have 1, and then we have another one. So we're going to have 4 x's. So we're going to have x to the power of 4. Then we're going to look at our y's. We've got 1, 2, 3, 4, 5, 6. So we're going to have y to the power of 6. But remember, guys, whenever you are in doubt, you can use the longer way and write it out and see what happens. So in this first one, you've got 2 x's and you have got 1 y. Okay, then we're timesing that by 1x and 2 y's. And then we are timesing that by 1x and 3 y's. And if you write it out like that, then it's very easy to see how many x's there are and how many y's there are, because you can see exactly the number. So whenever you are in doubt, write it out. It's never like a bad thing to have to do that. Just make sure that you know what's going on. Okay. And then when we're talking about signs, numbers, and variables, in this case, all of mine were positive, so I didn't need to worry about my signs. I wasn't multiplying anything by a negative. I didn't have any constants, so I didn't have any numbers before my variables that I needed to worry about. And then when we're looking at variables, you need to look at each base. So in this case, I looked at my x and I added up all of its exponents, and then I looked at my y and I added up all of its exponents. Sure, those of you who are feeling a little bit lost by this, if you can just let me know where you're feeling lost, that would be helpful. And then I can try and make that feel a little bit simpler or clearer. At which point, tell me if like this part over here, if that makes sense when we're writing it out. Yeah, Chi-Chi, how can I help?
How did you get to y to the power of 6?
Okay, so I've got 1 y over here. That's 1, 2,
Yeah.
3, 4, 5, 6.
Yep.
That's how the 6 came.
Oh, so like you took the exponents from the top and then you put them down into the y letters.
Exactly, because remember when we had 5 squared right at the beginning, that was the same as saying 5 times 5. So when we have y, it's just the y squared, there are 2 of them, and the y cubed, there are 3 of them.
Okie dokie.
Okay.
Okay.
Cool. Don't worry, when there are negatives, I promise I will help you and let you know what to do. Rational and irrational numbers, I'm not sure. Okay, let's see if we can try and bring in some numbers and things. All right, so this one should actually feel not so bad because this is actually something that someone asked about earlier. What happens if we have numbers instead of variables? So the first thing we need to look at is, are our bases the same? So are our bases the same? If the bases are the same and we're multiplying, then we are allowed to add our exponents. So the first question you're going to ask yourself is, are the bases the same? That's the first thing we want to ask ourselves. And then if we are multiplying, then we are allowed to add our exponents. Yeah, Eddie, are you going to give us the answer here?
Yes, ma'am.
Okay, what am I looking at?
So you would first have to simplify 2 over 4. I mean, sorry, ma'am. 2 to the power 4. I was busy with fractions earlier. Sorry, that's why I said that.
That's okay.
And your 2 to the power of 4 would give you 16.
Okay.
And then 2 to the power of 5 is 35. So 16 times 35
32, but yes.
is 512.
Yeah. So that is absolutely correct. So 2 to the power of 4 times 2 to the power of 5 is definitely 512. When they ask these questions, they're not going to want you to give a number like this. So that is what that's equal to. But when we're working with exponents, we want to keep our answer in exponential form. So what we would do from here is we would do the same idea as what we're doing. We'd keep that base the same, and we would just say 4 plus 5, which is 9. And we would just keep that as 2 to the power of 9. And if you put that in your calculator as 2 to the power of 9, you'll see you get the answer 512. But when we're working in exponents, we want to keep it in exponential form. Yeah, Chi-Chi, I see. How can I help?
Ma'am, Eddie's actually kind of correct, but then
Yeah.
like if like you could also do like 2 to the 2 times 2 times 2 times 2 and etc 2 times 2 like for 2 to the power of 5, who would actually still get the same answer.
Exactly, you would still get the same answer. So what you would land up with is you'd land up with a row of 9 2s, and that would be the same as 2 to the power of 9, which would be the same as 512.
Yeah.
Exactly, all the same. Okay, cool. All right, next one, I'm going to warn you before we get there. It's going to seem sneaky because you're going to be like, hey, we've just said something and now you're going to be doing something different. So I'm warning you that before you go into it, that there's traps all over the next question. But I want you to just try and think about it logically. Think about SNV, think about bases. Give it your best go. Don't overthink it. And tell me what you think the answer would be. So your clue is think about SNV. Think about what your answer would be. Pop it in the chat for me, and then we'll see how many of you can get this one right. Ooh, lots of brain buffs popping into the chat. I'm gonna give you a little bit of extra time. Okay. So what we have here is we have 2a times 3a squared. We're going to think about what's going on here. Signs, they are both positive, so we don't need to worry about our signs. Numbers, we've got a 2 and we're multiplying that by a 3. 2 times 3 gives us 6 because we're multiplying, okay? Then we look at variables. If we have different variables, we have to look at each of our variables separately. In this case, we've just got a's. So this a, at the moment, it doesn't have an exponent, but if there isn't an exponent, there would be a 1. So we have a, and then we've got 1 plus 2, which gives us 3. And so our final answer is going to be 6a to the power of 3. And the really cool thing with this question, guys, is how easy is this? And you get 2 marks for a question like this. Because you get a whole mark for figuring out that constant and a whole mark for figuring out the variable with the exponent. How cool is that? It's like marks just falling out of the sky. Well done to all of you who got that right. Those of you who didn't, I hope you see where you went wrong. If you don't see where you went wrong, just pop your hand up and we can chat about it. Yeah, Chi-Chi, how can I help?
Ma'am, don't we need to show the calculations though?
So there isn't anything we can show here because we would just be having the 2 times the 3. If you are wanting to write it out in a longer way, you could write it as 2a times 3a and go from there. But you wouldn't need to show that step.
Okay, thanks.
Sure. Eddie, how can I help?
Ma'am, the first thing I did wrong was I added the numbers.
Yeah,
So-
it happens. It happens.
Yes, I instantly said 2 times 3 to the power 2, and
Yeah,
then I got 18.
it's
And
very
then I
normal.
realized that that isn't right.
And that's great. And that's how we learn. That is exactly how we learn. But it is a very, very normal thing to do, guys. If you said 5, that's very normal. If you use the exponent and you had like 6 to the power of 3, that's also very normal. All of these mistakes are very normal. So all we've done here is we've looked at signs, numbers, variables. Our signs were both positive, so we didn't need to worry. Our numbers, we said 2 times 3, that gave us the 6. And then for our variables, we had an a and we had an a squared. So we were able to have a cubed. So that is what happened in this question. Okay. You guys are doing so well. I'm so proud. Let's try another one. I think we need to go to our brain break just now as well. Okay, so let's have a look here. Here we've got x squared times x cubed times a squared times a times x to the power of 4. Think about what you got to do here. Think about how your bases work. Think about what it means. Think about what we can add. It would be great if everyone could get this question 100% right. I'll be so excited. Oh, we got some answers coming in. Think about your bases. Also, there's sneak here. Don't forget about the sneaky sneak. I think some people are falling for that trap. Okay, let's have a look. Signs, numbers, variables. Our signs, everything is positive. Numbers, we have no numbers. There are no constants. Then we look at variables. So we look at each variable at a time. We're going to look at our x's first. Okay, all of those have the same base. If the bases are the same, then we are allowed to add the exponents. So we have x to the power of 2, and then x to the power of 3 and x to the power of 4. So we're going to say 2 plus 3, which is 5, 5 plus 4, which is 9. So we're going to have x to the power of 9. The way we got that was we said 2 plus 3 plus 4. Okay, then we look at our a's. Remember, when there is no exponent, there would be a 1. So we're saying times a to the power of 2 plus 1, which would be a to the power of 3. And you can write the times in between them, but you don't need to. So you could say x to the power of 9, a to the power of 3, or you could say x to the power of 9 times a to the power of 3. Both of those would be fine. Yes, Ertile, how can I help?
Hi, ma'am.
Hi.
So, ma'am, I was asking, ma'am, so, ma'am, is it fine, like, ma'am, let's say we're writing it in an exam,
Mhm.
where, like, if we separate it to, like, with the colors, just like you did it, ma'am, you think it's, like, acceptable, ma'am?
Absolutely. The best thing with exponents, like the easiest thing to do with exponents, your best friend with exponents is highlighters. If you have highlighters and you just highlight each of those different variables, like all your X is one color and your Y is another color, it makes it so easy for your brain. That's 100% okay to do at school.
Okay, thank you, ma'am.
Okay. Okay. Nice job, guys. You're doing really well. So just remember, all we're doing is we're adding the exponents where our bases are the same. And then we're just sort of lopping it together. Yes, Clement, how can I help?
Okay, ma'am, I wanted to ask if you can write the same answers. Like if you can have an exam, can you write the same?
So as in like, do you want to write that again? Is that what you're meaning?
Yeah.
You could, but they wouldn't give you any marks for it though.
Oh, okay.
Okay. Okay, cool. Let's have a look at the sky. Because I know it looks nasty, but actually now that we've spoken about things, it shouldn't be so bad. I want you to think signs, numbers, variables. Signs, numbers, variables. Signs, numbers, variables. So have a look at this question. First, think about your signs, then think about your numbers, then think about your variables. And once we finish this question, we'll go on to a brain break. Signs, numbers, variables. And don't panic about it, guys. One step at a time. Think about the signs. Think about your numbers. Then think about your variables. I'm seeing some good things. I mean, there are some things that are right and some things that are wrong, but I'm seeing like some things that are really great, which is awesome. Yes, Bongo Kukle, how can I help?
Ma'am, can you hear me?
Yes, beautifully.
Can I please share the answer?
Yes, that would be great. Can we do it in sort of stages? Can we do it step by step together?
Okay.
Okay, so let's first look at our signs. What would my signs be?
Okay, so at first it's positive
Good.
3 times positive 2 times negative 4,
Good.
which gives you a negative 24.
Yes, beautiful. Okay, so my sign was a negative and then my numbers are going to be 24 because I've got 3 times 2 times 4. Beautiful, 100%. Okay, now we need to start looking at our variables. So I'm just going to group them in colors. And then can you tell me what our final answer is?
Okay, so for our x, x plus x to the power 2, which is x to the power 3.
Mm-hmm.
And then another x, which is x to the power 4 now.
Yes, beautiful. And our y's?
And then we have our y. Our y is y, which is y to the power 1 plus y to the power 2 equals y to the power 3.
Yes. Woohoo! That was great. Well done.
Well done.
Nice job. That was a tough question. Okay, let's have a look, guys. If you're feeling lost by this, pop that hand up so we can talk about it. Tando, how can I help?
Hello, ma'am.
Hi.
So I just wanted to find out, where did you get the minus 24 x x from?
Okay, so the minus 24 came from saying 3 times 2 times negative 4. So when I multiply all of those together, that gave me my minus 24.
Oh, okay.
And then the x's was, there's one x, there's 2 x's, and then there's another x. So that gave me my x to the power of 4. And then here's one y, and here's another 2 y's, and that was my y to the power of 3.
So ma'am, if I'm understanding this correctly, you just used the signs, basically the constants, you added, you multiplied them together,
Multiply
the
them
x's
together.
and the y's.
Yes, exactly. That is exactly what I did.
Okay, ma'am.
Beautiful. Nice job. Jelena, yes, how can I help?
No, ma'am, I was asking the same question.
Oh, okay. Okay, no problem. I hope that then this makes sense. I think, I'm sorry, I'm looking at the time, guys, and I'm just like, we're going to do a quick brain break and then we can jump back into some questions. Yes, there is questions where you have to subtract exponents instead of adding, but not today, because today we're only learning about the first law. So this question looks more confusing than it is, guys. The star that is in this picture is made by fitting together 12 congruent. So congruent means exactly the same, okay? Equilateral means all the sides of my triangles are the same. The perimeter of the star is 36 centimeters. What is the perimeter of the gray hexagon? So the star shown in the picture is made by fitting together 12 congruent equilateral triangles. The perimeter of the star is 36 centimeters. What is the perimeter of the gray hexagon? I have gotten an answer coming in the direct chat from Eddie. You are 100% right. I'm not going to say it just yet, but well done. Keep the guesses coming, guys. Just see what you can do. So the perimeter of the star is 36 centimeters. What is the perimeter of the gray hexagon? Shoot, we're getting a very big number here. Oh my goodness. Yes, I promise I will go on to the joke before we go to the questions. 18. There we go. There we go. So guys, so because they're equilateral, it means all of these are the same length as each other. All of them have the same length. And so if the perimeter, because the perimeter would be the outside of the shape, the perimeter is 36 centimeters. So we would say 36 divided by 12, which gives us 3. So that means that each one of these sides is 3. And the perimeter of my hexagon is 1, 2, 3, 4, 5, 6. And each of those is 3, which means that the perimeter of my hexagon would be 18 centimeters. So well done to those of you who got it. And your joke for today. My girlfriend is the square root of -100. She's a perfect 10, but purely imaginary. So for those of you who have done imaginary numbers and non-real numbers, you've got your joke of the day. So you can't have a square root of a negative number, guys. It doesn't exist. It was sneaky. So if any of you don't have a boyfriend or a girlfriend and you want to pretend you do, you can say you do. They're the square root of -10. That's how hot they are. And you'll be fine. Yeah, he does. All right, let's try and give some of these questions a go. I want to see if we can find. Let's try this one. Okay. So try and think about everything we've spoken up until this point. So now here we've got 3 variables. We've got m and n and p. Don't fall for the tricks where we don't have exponents. Be careful with that. So think about what those exponents would be, and then tell me if you can figure out what this answer is going to be. And we've got m, n, and p. Do some little thingies here. Try and help out. Because I know it's difficult sometimes when you're on a screen. Okay. Yes, Annalena. Do you have an answer for me? Or a question? No? Let me try Fareed. Hello? Hi. Oh, I can't hear you very well. I think there's something happening with your sound, Fareed, because it sounds like you're very far away. I'm not too sure what was going on there. I'm so sorry. Okay, so when we have a look at this, I'm seeing some great answers coming in the chat. We're going to look at our M's first. So I'm just going to write it out the long way. Remember, you don't need to write it this way. I've got 2 plus 3 plus 1, because we can't forget that sneaky 1. All right, just make that a bit neater for you guys. And then our N's, we've got 1 plus 2 plus 1. And then our P's, we've just got the 1. So what that lands up being is m to the power of 6, n to the power of 4, and p, you can say p to the power of 1, or you can just say p. It doesn't matter. It means the same thing. So you can say p or p to the power of 1. How did this question go? Have we made progress? Did this feel easy now? Let me know. Let me know how this question went, and then I'll try and answer some of these questions. Tabatso, how can I help?
Hi, ma'am.
Hi.
I was asking a question of, is it possible for the M to add it up and make it a 7? Do we add the M also?
No. So you only add these numbers. So you're only saying the 2, the 3, and the 1.
So as it is, it's gonna be M6, A4, and P1, or just the P?
Or just the P, yes.
Okay, thank you, ma'am.
Okay,
Thank you.
nice, no problem. Yay, guys, I'm seeing good things. Chi-Chi, how can I help?
Ma'am, while I was doing the question, I want to ask a question about if you have, like, for example, if you have 3 M's, so should you just say like what's the question? Like, should you put like 3 M's? No, should you like divide them into like M times M times M, or you just put the numbers on top and then plus them together?
Yeah, so if you just had like M, we would just write that as M cubed.
Okay.
Okay.
Because it caught me off guard, because while I was when I was doing the equation, I did a wrong mistake and then I did it again and then I got my answer.
Okay. Yeah, no, I mean, these ones are sneaky and they take time and they take practice, but we will get there. You're doing good and you're asking good questions. I'm worried I'm going to say this name wrong, but I'm going to try. Is it Atani? Hope I'm saying that right.
No, ma'am.
How can I? Okay, how can I help?
I wanted to ask about the last question, the 24 one.
Yeah, sure.
The one we did before the break.
Yeah, let me just pop back up there. There we are.
Yes, and that one. I wanted to ask, can we like put the variables so in like brackets with the same variables together before we actually get our answer?
So like moving them around. So write this as
Like
negative 24 and then x squared x and then y squared.
No, I said like before solving it, we put 3 times 4, like 3xy by 4xy and then multiplied by 2x.
Yeah, you can absolutely do that. You can do it in stages. That's 100% fine.
Okay.
Totally fine to do that. As long as you're not messing with the signs, it's not a problem at all.
Yes, thank you.
Okay, no problem. Yeah, Tabatso, how can I help?
Ma'am, as she was saying, how many marks could you get are you gonna get marks for breaking the method down?
No, so for these questions, it depends on where it's sort of in a test and how many marks the test is out of, but generally you would get 1 mark for saying the minus 24, 1 mark for the x to the 4, and 1 mark for the x cubed, for the y cubed.
Oh, okay. Thank you.
So like you don't get marks for anything in the middle.
So if we don't break it down, there is no problem there. Okay, thank you, ma'am.
No problem. Okay, I think we will probably only have time for one more question. So I'm gonna try and give us a spicy question. So we can finish off with something nice and spicy. Let's try this one. And then we can see how this goes. Nice and spicy. End of our lesson with some chili for our Tuesday evening. And how great will you feel if you get this one right? You're gonna feel amazing. I'm seeing lots of answers. Think of our rules, think about signs, numbers, variables. Mm-hmm. Davian, have you got an answer for me?
No, ma'am. I was trying to ask if we can like ask the questions from our book.
I don't think we'll have time for that in this lesson, but maybe in one of the consolidation lessons. Teacher Sam will be able to do that with you.
Okay, ma'am.
Sorry, Davian. Nalitando, do you have an answer for me?
Yes, ma'am.
Okay, tell me what to do.
Ma'am, 3 times 4 times 2 equals to 24.
Yes, it does. Okay, next.
And then, ma'am, 9 plus 3 plus 2 equals to x 14.
Beautiful.
And then, ma'am, 3 plus 7 equals to y 17.
Look at you, guys. Well done, man. You guys are brain buffs, and I see the chat not even that spicy. You guys are so, I'm so proud of you. SNV stands for signs, numbers, variables. That's what that SNV stands for. So signs, the first thing we look for is our signs. Do we have positives and negatives? The second is our numbers. So we need to multiply all of our constants together. So we multiply the constants. And then for variables, we look at our X's and our Y's. Nice job, guys. Little brain buffs.
Well done.
Annalena, I think I'm also saying this name wrong and I'm sorry. How can I help? Yes, have it. Look. Good, guys. I'm glad you're finding this nice and easy. That is great. Should we try and sneak in one more question? Elisa, do we have time?
Yeah, 3 minutes. As long as we'll be done in 3 minutes.
Guys, we can be done in 3 minutes, right? Because we're brain buffs. We're all very, very smart. We're little brain buffs. We'll be fine. I think we'll be okay. Okay, guys, let's see. You are on a very strict time limit here because we've got to get to our next class. So, quickly solve this for me. Tell me what my answer is. Think about your signs, think about your numbers, think about your variables. And then give me my beautiful answer. And then you're going to fill in your poll with Nelisa. And then I will see you sometime in the future.
Hopefully soon.
Yeah.
'Cause we love
Next class is on Thursday. You'll be with Teacher Sammy again on Thursday.
Yes, sir.
Okay. 1 more minute and then I'm going to put the answer on the board because then I got to leave you guys. Nice. Awesome. Okay, so our signs and our numbers, we've got -3. So we've got -3. Then we're going to look at our variables. We've got a to the 12 and a to the 6. So that's going to be a to the 18. Sorry, my students always get cross with me because my a's look like 9s. And then b, we have got b to the power of 5. And so you would get 1 mark for the -3 and 1 mark for that a to the 18, b to the 5. If you got that, a big well done. I'm very proud of you guys. Stick around to do the polls, Neliswa, and I will see you at some point in the future.